Okay, this is week 4. We're going to be going over chapter 3, and this is on internal memory. And as programmers, you have the ability to assign memory locations within our application by declaring what's called declarations within our code and declaring those declarations as a data type to store it at. Two types of memory locations a programmer can declare: variables and constants. A variable is a computer program or computer memory location that temporarily stores a variable for a certain function or purpose within an application. The contents can change during runtime. Example of a variable change could be a counter of an application, something that counts within the application as it's running. It's useful to use a meaningful variable name to reflect it. So if it's a counter, you would name, somewhere in the name would be the word counter. If it was, for instance, like an integer, be int counter. Int would be lowercase, c would be uppercase. The book does declare use camel case. I use more of the book case throughout my programming. So variable names should conform to naming rules. Each variable must be assigned a data type, which determines the memory location. Here's some data types that could be declared as variables: integer, long, short, decimal, double, single, char, and string. Unicode's the other type. It's a universal coding for characters that assigns a unique numeric value to each character. Other data types could be Boolean, date, and object. This screenshot here just defines it more clearly, and in the book goes over each more detail of the different data types. So when you declare a variable in code, you have to have some type of declaration statement. And the scope keyword to declare a variable, the very first word to use, is either dim, private, or static. You name the variable and then assign it a data type. Optional is to give it an initial value of some type. Numeric data types usually or do automatically initialize themselves to 0. Strings initialize themselves to nothing. And Boolean, false. So here's an example of declaring hours and pay rate. Hours, dim hours is integer, dim pay rate is double. And declares an integer variable named hours, and double is named pay rate. The variables are automatically initialized to 0. Example 2, dim discount is decimal. Because there's no equal sign to the right of decimal, the initialization will be 0. Next is a dim is date okay as Boolean equals true. This would be initialized as true because it's equals true, right of the assignment operator. And the equal operator is actually called the assignment operator. Example 4, dim message as string equals good morning. This declares a variable and assigns it an initial good morning string. So the assignment statement is used to assign values to a property. It's used to assign values to variables. The assignment operator is the equal symbol to the right of the data type. Literal constant is an item of data whose value does not change while it's running. An example would be a literal constant like, say, tax rate. Numeric literal without a decimal is treated as an integer. A numeric literal with a decimal is always treated as a double. String literals are enclosed always in quotation marks. So in this example 1, we have dim quantity as integer, and then quantity equals 650. The assignment statement assigns the integer 650 to quantity. Example 2, dim first name as string, assigning James to first name. Example 3, dim zip code as string, assigning the contents of the zip text box to zip code. Example 4, dim discount percent as double, assigning 0.05 as discount percent. TryParse is the other method that this chapter starts out with talking about. We actually use in the application this week. A specific portion of a class instructions that perform a task for the class is a method. So TryParse method is part of every numeric data type. And when you hear the word method in programming, every object you put on a form within Visual Basic has an object name, which you're familiar with. And when you double click on that object and it goes into code view, on the right side of the code view you see the object method. Let me show you what I'm talking about. For the application this week, Tile Limited, I'll just use the calculate button here. You'll notice calculate, but BTN calculate button's a name over here on the left side, but on the right side, notice all the events available for that name. For that object, button click would be one of them, but there's a whole bunch of other methods available to it as well. So, continuing on with TryParse, what it does is basically every integer within that is declared, any type of data type that is declared, does have a methods. So it would be an integer, a double, a decimal, has what's called a TryParse method. The argument for TryParse is two parts. The string, which is a value that you're converting, or is being converted to, and then the variable, which is a location to store the result. So if TryParse conversion is successful, the method stores a value in the variable. If it's unsuccessful, a 0 is stored. So here's an example. 1, dim sales is double.TryParse, and then in parentheses, the first argument is going to be the string, in this case is a text box. Second argument is plugging it into sales. So if sales text box is not a double, then it's going to be 0. Example 2, dim gross is decimal.TryParse. Object is gross text box. Again, if what the user types in the gross text box is not a decimal, it's going to become a 0 in the gross variable. Example 3, dim int number is string equals 34 in quotes. And then notice the next line, dim number is integer. Here using the integer.TryParse to the integer input number 34 and tries to convert it to a integer and then put the results 34 in an integer. So TryParse's encoding are actually used to really do validation of input. Otherwise, if you didn't do a TryParse in a text box that was used for calculations, it would crash the application because it would not know what to do with that text box information. An example is if you had a text box that needed to put in the value of a number, like this week's program, length, feet, and foot. If you put, for instance, A, B, and C, if you did not use TryParse, this application would crash because the compiler would not know what to do with that text. This is just an example of TryParse conversion. I'll just go over a couple of these. A string 62 to a double becomes 62.0, be an integer 62. Let's go over this one here, string $5. The dollar symbol here is going to throw the error here, or throw the error in conversion. So this is going to be 0, 0, and 0 all the way across for double decimal integer. Same thing with percent. Cannot convert percent symbol into a double decimal or integer, thereby it's going to be 0. Same thing with this one, has an A. Space here on this one. Empty string on this one. So really TryParse, you can think of it as also a way of validating input from users as they go through. Validating that it's going to be either a valid number or a 0 if they don't enter a valid number or no number whatsoever. Next is a convert class where you convert numeric values to specific data types. Common ones are to double, to decimal, to int32, and to string. Example 1, dim tax rate is decimal. Tax rate equals convert dot to decimal 0.15. This converts the number 0.15 to a decimal and assigns it to the tax rate variable. Example 2, dim total store as integer equals 73. This one's converting to a string total score and putting it in a label, total label. Arithmetic expressions. There are arithmetic operators used within Visual Basic, and we'll use some this week, used to perform calculations. You do have there, like in all mathematical calculations, a precedence indicates the order in which an operation is performed. If an expression has two operators in the same precedence that are evaluated from left to right, parentheses, however, allow you to change and override the order evaluation. Integer division divides two integers and returns an integer value. The mod operator divides two numbers and returns a remainder or leftover of a divisional statement. So an example here, in the order of operation of arithmetic expressions, the exponentation raises a number to power, negation, multiplication, division, integer, modulus, addition, subtraction. And on the right is the order of precedence. The order of precedence will always take place unless there is parentheses in an argument. And this example here just shows some of the examples of integer division and mod operators. 211 divided by 4 is 52. 211 mod 4 is 3. All the way down, showing you what it does for division and mod all the way down. Here's showing parentheses being used on the top portion and the bottom portion. So let's look at the top portion first. 7 minus 8 divided by 2 plus 5. 7, the division is performed first. 7 divided by 4 plus 5. Then subtraction is performed next, 3 plus 5. Then addition is performed last. Should be the other way around in this example. The division is performed first, addition is performed next, and then subtraction is performed last. Next, original expression, 7 minus 8 divided by 2 plus 5. You notice parentheses around the 8 divided by 2 plus 5. The division in this example is going to be performed first. 7 minus 4 plus 5. Addition is performed next, and then subtraction is performed last. Expression containing more than one operator can have the same precedence. So in this example here we have example 1, age is integer is 35, age plus 1 going into age is going to change it to 36. Example 2, dims dimes is integer, changes integer. equals 123. Change divided by 10 is going to put the value of 12 into dimes. Dim sales is double, 2,075. Dim bonus is sales. Bonus equals sales times 0.1. We'll put the value of 207.5 into the bonus. Dim price is decimal equals 20. Price equals price times convert.decimal 1.04 is going to assign 20.8 into price. And then finally, dim sales is double, 2075. Convert to string sales times 0.1 is going to put 207.5 into bonus labels.sales. So the arithmetic assignment operators abbreviate an assignment statement that contains an arithmetic operator for specific cases. The statements must be in the form of variable name equals, variable name, the arithmetic operator, and then the value. Order of precedence here again, as far as using these operators, you do have a plus equals, which is an additional. A minus equals subtracts an assignment. Times equal multiplies the assignment, and divide equals divide assignment. In programming, this one also is called increment and decrement as well within code. So in this example here, in the original statement, age equals age plus 1, abbreviated statement, age plus equals 1. It's going to be incremented by 1. This one, price equals price negative or minus discount, price negative or minus equals discount, be a decrement. This one's doing times, and this one's doing division. In programming also, there are such things as scope of the lifetime of a variable. The lifetime indicates how long the variable remains in memory. A variable can have a module scope, meaning program level, procedural scope, form level, or block scope, function level. So a variable scope and lifetime are determined where you place the declaration of the variable. If the variables are declared in the form declaration section, they do have what's called a class scope for that. Variables declared in the procedural either have a procedure scope or block scope. Procedural level generally starts with a dim keyword. Procedural scope, only the procedure can be used in that variable. And with procedure level scope, two procedures can each use the same variable names. So if you have a procedure called calculate and a procedure called save, both procedures could use a variable name called sales because they're in two separate procedures. Comments, always use comments. They are internally for documentation purposes, especially from here on out in your programming. When you start using more lines of code and more calculations, and comments are always going to be helpful when you come back later to a program. They are ignored by the compiler, and they do appear in green, and they start with the apostrophe operator. So as in this example here of a calculation, sales tax calculator, you'll notice the comment is appropriate, saying it's calculating at 2% sales, declaring some variables, sales and tax, both as double, and then doing a calculate and displaying the sales tax. The information that's in green, which is your comments, can actually come from a toe chart. If you use a toe chart before you create an application, converting the actual steps of from a toe chart into comments within procedures. In this case, it's the procedure for the Calc Tax To button click event. So it does a TryParse here, takes the sales times 0.02, puts it in a tax2, and then converts it into a label as a string. Next example, calc tax 5. Again, your comments, then declaring two variables, another TryParse, kicking it to a label. So variables with class scope, variable can be used by all procedures in the form. This will be labeled at the top of the form within your application, and generally starts with the word private as a keyword. So you'll notice that this form here called public class main form, this private statement is at the very top of the form before any procedures, any button clicks, events. And so this variable will be used throughout the life cycle of the form while it's open and resident and focused in the application. Procedural level lives during the click event only, here for the calc button click and also for the exit button. Static variable is a procedure level variable that remains in memory, retains its value even after the procedure ends. It retains its value until the application ends, but it can only be used by a procedure in which it's declared. Same life cycle as time as a class level and narrower scope. This one starts with the keyword static. So in this example here, in the calc button click event, there is a static variable called total sales. And total sales is actually going to be used within this function, and it will live as a static variable value until the application ends. Name constants, memory location whose value cannot change while the application is running. It starts with a const keyword, and it's a good programming practice to specify the data type as well within a named constant. Programmers use a Pascal, many programs use a Pascal case for named constants. There's a literal type character which forces a literal constant to assume a data type, and named constants help to document the program code. So here's an example of some named constants. We have const pi as double, const max hours as integer, const tax rate as decimal. You'll notice in this example the letter D basically means it's a literal type character that changes a number to a decimal data type. Private const heading is string with ABC company, initializing the string constant heading. So in this example for the area calculator, for the calc button click event, you'll notice a constant declaration of const pi as double with the equals of 3.141593 being used below in the calculation area for area, pi times radius. Undeclared variables. This goes starting with what's called option explicit, infer, and strict. A variable that does not appear in declaration statement, such as a dim statement, is assigned a data type in Visual Basic as an object. Misspelling a variable can result in an undeclared variable unless option explicit is on. Option explicit on statement appears in the general declarations of your form and forces that all variables must be declared before they are used. Infer off ensures that every variable declaration has a data type, and type conversion occurs when you attempt to assign data of one type to the variable of another type without explicitly attempting to convert it. If you're converting a data type that can store large data numbers, the value is said to be promoted. If you do the reverse, where it only stores small numbers, it's tended to be and named as demoted. So, conversion rules. Here we have strings will not be implicitly converted to numbers, and you will get a warning message by doing this. So dim hours is double. Incorrect way to use this would be hours equals hours text box dot text into hours, which is a double. Well, the text box is a string, so you would need to do a double dot TryParse and parse it into a double from that text box, and then declare it into hours. Next example here is dim gross pay is decimal. Incorrect way is the gross pay decimal into a text box, which is a string. Correct way is to convert that gross pay into a string and then place it into the gross label.text. Third is incorrect way of declaring a rate as decimal is 0.5. Correct way is putting a D to the right of 0.5, which converts it. You could also do a convert.toDecimal as well. And then narrowing data types, you dim num as integer equals 3, dim total is double, 45.15. Div average is double. Correct way, average equals total divided by num. Option strict statement ensures all values cannot be converted from one data type to the other, resulting in lost precision. And this should be placed at the top of your code before you begin developing applications. This is a screenshot of the Sunshine Cellular interface from Chapter 2. Flowchart. Pseudocode, basically taking the flowchart and putting it into simple language. So a procedural pseudocode for this would be for the calc button click event, assigning a user input, silver phones or blue phones, total phones ordered equals silver phones ordered plus blue phones ordered, subtotal, total phones ordered times phone price, sales price equals subtotal times sales tax rate, and total price equals subtotal times sales tax. Display total phones ordered and total price in the total labels, total phones labels, and total price label. Then a clear button click event clears all the text boxes, all the 7 text boxes. It also clears the labels and sends the focus back to the name text box so the user can be able to enter the name, and the exit clip button exits the application. I'm going to go right into the application now. You can continue this on your own as far as in the PDF for this. I'm going to go to the application for this week, which is time limited, and I've already got it running here and got it corrected on everything. In the code declaration at the code view for the main form.vb on this one, I do have a challenge this week for this one, which you get 20 points for doing, is adding a clear button to the logic for the application and clearing all text boxes on that screen and also labels, and then focusing back on the text length text box. And as always, put your declaration information at the top. So we have on this form, the logic for this one is length, width, price is what the user enters. They hit calculate and it comes up with an area and total price. The clear button clears out all of these objects, and then exits the application. So we have here 1, 2, 3, 4, 5 labels, 1, 2, 3 text boxes, 2 other labels for the output, and then 3 buttons. So let's start with the calculate button. The calculate button is going to calculate the area and total price, declaring this one 5 decimals, length, width, SQ foot price for square foot price, area, and total price. Some TryParses to validate user input and make sure that it's an actual number the user's entered in for length, width, and square foot price text boxes, which would be these right here. Then it takes those values and length times width, which comes from here, length, width, into area, and then area times square foot price, which is found right here on this line. Then it's going to kick those information out to some labels. Label area price equals convert.toString area. Then label total price label, total price.toString C2. And what this is doing is taking this total price here and converting it, and then setting it to the focus back to the text box. The clear button just does that, clears all the text boxes and labels, and then sets the focus back on the text length text box, which is this one right here. And the exit button connects to the application. As I said last week, do recommend using the application.exit versus the me.close. Okay, let's go and run the application here. Notice the cursor is blinking in the length text box. I'm going to go put 25 for length, 25 for feet. I'm going to do 35 price per square foot. Click calculate. There's the area. And then it takes that total price and converts it to a currency of $21,875. Clear button will clear all text boxes, labels, and put the focus back on the length. One last thing on the total price conversion string here. Total price.toString C2. What this does is it converts the total price, which is a decimal, to a currency, and then puts it into the label total price label.txt. Okay, that concludes the week 3 application for Tile Limited. Remember, the challenge is the book doesn't have you do for this tutorial the button to clear data, but if you want to add that to your code and add a button on your form to clear all data on the screen and place the focus on text length text box, as I've done here, 20 points extra. And if you have any questions, you can email me as always with an eagle. Otherwise, have a great week.